An absolute value function is a function whose rule contains an absolute value expression. The graph of the parent absolute value function, f of x equals the absolute value of x, has a V shape with a minimum point or vertex at 0, 0. As you'll notice in the table, the absolute value parent function f of x equals the absolute value of x has a domain of all real numbers. Domain is our x values. Our range, or y values, include any non-negative real numbers. Our vertex of our parent function is 0, 0. The graph of g of x equals the absolute value of x minus h plus k is the image of the parent function, f of x equals the absolute value of x, after a horizontal shift of h units and a vertical shift of k units. So the vertex is at h, comma, k. Just like with our quadratic functions in vertex form, our vertex is at h, comma, k, which makes it easy to remember. Keep in mind the general form for translations. Vertical, we have g of x would be f of x plus k, where k is positive if we move up, k is negative if we move down. A horizontal translation, g of x equals f of x minus h, where the h value alone is positive when we move to the right and negative when we move to the left. A reflection across the x-axis changes the y values, so the entire function, everything in the function, becomes the opposite, so negative f of x. A reflection across the y-axis only changes the x values, so we have the opposite x value, so f of negative x. A vertical stretch and compression. A stretch and compression vertically is multiplied by a factor of a. If a is greater than 1, then we have a stretch. If the absolute value of a is between 0 and 1, we have a compression. A horizontal stretch and compression only changes the x value, so we have f of 1 over b times x. Again, if the b value is greater than 1, it's a stretch. If the absolute value of b is between 0 and 1, we have a compression. The main difference between our translations and our reflections, stretches, and compressions, as you'll notice, translations, we're adding and subtracting values. For our reflections, we're doing the opposite, so multiplying by -1, either the entire function or just the x value. For stretches and compressions, we're multiplying by a factor or a certain amount. For vertical, we multiply by the number. For horizontal, we multiply by the reciprocal of the number, or 1 over b. In chapters 2 and 3, we had studied linear functions in the form of f of x equals mx plus b, which is slope-intercept form. A quadratic function is a function that can be written in the form of f of x equals a times x minus h squared plus k, where a does not equal 0. In a quadratic function, the variable is always squared. The table below shows the linear and quadratic parent functions. The parent function that's linear, we have an input of -2 would give us an output of -2. An input or x value of -1 would give us -1 for our y value. 0 would render 0, 1 would render 1, 2 would be 2 for our y value. As you'll notice in the quadratic parent function, using the same input, the same x values, -2 yields a +4. -1 gives us a +1 for our y value. 0 gives us 0. 1 gives us 1 and 2 gives us 4, thus giving us a parabola. Here's a larger image of those parent functions. Translations of quadratic functions horizontally change just the x value as with any other translation. Horizontal shifts, we're going to use h for the value of our shift. F of x minus h is our new value. So x minus h squared is what we use for a quadratic function. If we move to the left with the quadratic function, or with our parabola, if we move the parabola to the left, h is a negative number. If we move our parabola to the right, h is a positive number. Now keep in mind, it gets a little confusing sometimes, it's x minus h. So if h is a positive value, for example 2, it would be x minus 2. If h is a negative number because we move to the left, say negative 2, for example, it would be x minus h. If h is negative 2, it's x minus a negative 2, which now becomes x plus 2 squared in parentheses. So it's basically the opposite. Vertical shifts of k units, we're going to add it to the entire function. So if we have x squared, it now is x squared plus k. Same as before, k is positive for a move that goes up, k is negative for a move that goes down. For reflections, if we reflect across the y-axis, we're only changing our x values. So f of negative x gives us negative x squared, which is still x squared. However, reflections across the x-axis change the entire equation. So f of x equals x squared now becomes negative f of x, which is negative x squared. So we flip across the x-axis. This basically indicates that when we have a negative for our a value, that means that the parabola opens downward. If we have a positive number for our a value, our parabola opens upward. For stretches and compressions, same as before, a horizontal stretch or compression by a factor of b means that you take 1 over b times x, all of it squared. For a vertical stretch or compression, using an a value, you multiply the entire function by that a value. If the absolute value of b or of a is greater than 1, you have a stretch. If the absolute value of b for horizontal or absolute value of a for vertical is between 0 and 1, you have a compression. Okay, keep in mind the main difference between horizontal and vertical. Horizontal is the reciprocal, it's 1 over b, whereas vertical is multiplied by the actual factor itself. If a parabola opens upward, it has a lowest point. If a parabola opens downward, it has a highest point. As you remember, the lowest or highest point is the vertex of the parabola. The parent function f of x equals x squared has its vertex at the origin. You can identify the vertex of other quadratic functions by analyzing the function in vertex form. The vertex form of a quadratic function is f of x equals a times x minus h squared plus k, where a, h, and k are constants, which means they're numbers. The a value indicates to us a reflection across the x-axis, so it tells us if it's positive it opens up, if it's negative it opens down. It also indicates a vertical stretch or compression. If that a value is greater than 1, we have a stretch. If it's between 0 and 1, we have a compression. The h value indicates a horizontal translation, so moving left or right. The k value indicates a vertical translation, moving up or down. Thus, our vertex is at h, k. This is the end of our review for the transformations unit. The test will be covering questions similar to the classwork for 1-8, 1-9, 2-6, 2-9, and 5-1. I would highly recommend that you review those questions when studying for your test.